Chris and his toy. Or it's a machine.
Speaking of surveillance.
Well, one of the things that drew me actually to Barrett a long time ago now, the early 90s, was Wired magazine. And Wired had a run there, the original crew in the 90s, and then the second great era of Wired magazine was really driven by Chris, who was the editor-in-chief for a dozen years, and is probably known by most of you out there for that, and also for his really singular work, like his best-selling book, The Long Tail, that kind of built off his work there at Wired. But there was a point that he started shifting his thinking to the maker movement and the world of things. And it actually is now to the point where he is now the head, the founder, and running a company called 3D Robotics, which has got 350 employees here in Berkeley, or at least rooted in Berkeley here, and is clearly in the world of things, in the world of drones. And so we're going to welcome you here, but just tell us a little bit about that shift. That's a big shift, and what really was driving that, and why did you do that?
Thanks. It was a case of parenting gone horribly wrong. So it's 2007. I've got 5 children, go to school at Berkeley High and French school down the road. And my wife and I were trained as scientists. We're always trying to get our children interested in science and technology and kind of coming up with weekend projects that will stimulate them in this. And one weekend on a Friday, I was at Wired, and we got these review units in for, you can take home on the weekend as long as you promise to review them. And one of them was a Lego Mindstorms robotics kit. And the other was this remote control airplane. I thought, this is gonna be awesome. We'll build a robot on Saturday, we'll fly an airplane on Sunday, something's gonna stick. And so we did this on Saturday. We built the robot, a little kind of rolling thing, and and it just it rolled very slowly to the wall and backed up. And the kids are like, "You've got to be kidding, right? We've seen Transformers. Where are the lasers?" Hollywood has ruined robotics for children. You just cannot compete with CG. I'm like, okay, well, just wait. Tomorrow we're going to go to the to the park, and we're going to fly an airplane. And so we watch YouTube videos of acrobatics, and we go to the park, and I immediately fly it into a tree, and they're like, "That sucked." So I thought, how could that have gone better? And I thought, well, what would have been a cooler robot and a better flying plane? And I thought, what if the robot flew the plane? And so I literally Googled flying robot, and the first result was drone. And then I Googled drone, and the first result was autopilot. And I Googled autopilot, and there was a lot of math about Kalman filters, so I kind of stopped Googling. And I just said, kids, let's do this. And we sat there on the dining room table, and we put together a little Lego autopilot with sensors, and it's got, the Lego Mindstorm is amazing. It's got accelerometers and gyros and all this kind of stuff. We put it together, we stuck it in the plane, we got the 9-year-old to write the code, and it flew. Not well, but it did fly. The kids lost interest instantaneously, and I was like, what just happened? How is it possible that a dad and his kids can Google flying robot and build a drone on the dining room table with toy parts? And so I started a website to ask that question, and the rest is history. Today our company makes more drones than all of the U.S. aerospace companies combined every week. It's just a freaky world we live in right now, where hardware is now as easy as software to do extraordinary things with, and that's because of smartphones. The smartphone technology is basically transforming hardware industries because the parts are so good and cheap.
Well, so there's a kind of, people are familiar probably with the consumer side of the drones a little bit, but push them how far that's actually, what you can do with that now, and then we'll get to commercial in a minute here, but this is essentially available for anybody for like $1,000 or something.
Yeah,
right?
yeah, so the drones started as kind of part of the, this movement of personal storytelling. It's GoPro and, and Instagram and Facebook, et cetera, but basically we have the tools of Hollywood in our pocket. Our phones have great cameras. It's easy to share video, and what we're missing are the skills to take truly cinematic, movies of our lives. Now we're getting better at it, but one of the things in the toolkit, the Hollywood toolkit, are like cranes and booms and helicopters and things like that. And we're left with the selfie stick. So if you want to truly tell the story of your life in a cinematic way, you need a crane and a boom or whatever, which you don't have. You need skills, which you don't have, and so we just turned it all into software. So these things are autonomous. You just push a button, and they program to take sort of cinematic reveals and arcs and rotations around you, just tracking you and following you, as like your little personal Spielberg.
Well, I know you have, coming from Wired, you have the bigger vision of really what's the opportunity here.
Yeah.
And so talk a little bit about really what we're on the kind of edge of here. What's the frontier that you're starting to see opening up out there?
Yeah, so right now we're in the consumer phase of this, but much more interesting is the commercial side. So these things, one of our mutual friends, Stuart Brand, from the Whole Earth Catalog, and just a mentor for all of us and a legend. At the dawn of the space age, he was an environmentalist, and he asked NASA to see the whole planet. He said, show us a picture of the whole planet, and this was the picture, and it caused us to think differently about the environment and about our world. We could think globally. It went from air pollution to climate change. And that was due to the space age. That was due to satellites. Satellites are great, but they're far away, they're expensive, they're owned by governments and a few small companies. And we have an opportunity to now use drones to do the same thing, but at much higher resolution. This is what a farm looks like from a drone. And what you're seeing right there is these crops. Those crops are circular because that's the way the irrigation and the fertilizer spreaders work. But the one closest to us has been analyzed by a drone to look at the variation in the soil and the plants and the water. And we've been treating crops, the reason we go with monoculture is because crops are too big and there's too few people on them. Once upon a time, farmers could walk the fields. Now they can't do that anymore. So instead, they resort to predictable monoculture. They treat the whole field as a one-size-fits-all thing. But, the nature isn't like one-size-fits-all. And so what the drone does is it evaluates the field in terms of these differences in the crops and the soil, et cetera. And then each one of those pixels, if you will, corresponds to a nozzle on that boom that sweeps out and can spray. And so you can actually do precision agriculture. In the same way we talked about personalized medicine, kind of getting out of the one-size-fits-all model, we can do that with agriculture as well by having the data to look at the farms through multispectral analysis over time from the air and recognize that we don't have to resort to monoculture or prophylactic spraying of chemicals. If only we can measure agriculture, we can manage it with much more precision. So what really excites me is the notion that drones, which you think of as a military technology or maybe a toy technology, is in fact an agricultural technology, it's an environmental technology, that drone, that very drone which took these pictures, can actually lower the chemical load in our food and our environment.
So you even have a bigger, you think of this as, there's the next frontier that you said, you've talked to me before a little bit about the digitization of the world, and space, but the in-between opportunities. Talk a little bit about how you see the big opening here for digital technologies.
Yeah, so the big history of the last 20 years was the digitization of our screen lives. Well, not there's the recording of our screen lives. So, the clicks and the cookies, et cetera, we now manage the web with incredible precision. And as a result, a lot of culture, all digital culture, has become we've closed the loop. It's, the feedback loops, et cetera. The Googles and the Facebooks of the world are really good at watching what we do and managing it, for better or for worse. But the physical world is much harder to manage because it's not digital. And so what we need is some way to digitize the planet so we can manage it. And I've given you one example in agriculture, but construction and the environment are all ones that want to be digital, so that we can close the loop and start to actually record what we're doing. But it's hard to do. Satellites are just too expensive. This is another example of just 20 years ago we debated with wireless communications whether it was going to be satellites or cell phone towers. And at the time, it seemed like a no-brainer that it would be satellites. 64 satellites, a constellation of 64 satellites, could cover the planet and provide phone coverage over the entire planet. Why would you put up millions of cell phone towers when you could put up 64 satellites? Well, we know how that story turned out. Cell towers won. Now, why did cell towers win? The answer is they scaled. Those first satellites were designed for voice. But the cell phone towers could go from voice to data. Supply creates demand. Our appetite for data was essentially infinite. And the cell towers could scale. You could change the technology. You had fiber backhaul. You could put the capacity where it was needed rather than having to cover the whole planet at once. The same thing are happening with drones. We can now put sensors of infinite resolution, at almost no cost where they're needed most. And so now we have a technology that can scale to digitize the planet the way satellites couldn't.
So what does that open up? You've talked about how we can actually watch in real time things happening, and talk a little bit about your kind of the opportunities of seeing the world when it's ubiquitously surveyed at that level.
Well, you can see three things from the air so the question is, what can we see with sensors in the sky that you can't see with the human eye? And there's three things. The first is just the aerial perspective. It's a different perspective. I'll show you in a second. The second is that we can see beyond the human spectrum, the visual spectrum. So we can see into the infrared. And the world, for example, water is a huge issue in California right now. We can spot leaky irrigation in a way that you can't see with the human eye. When irrigation leaks in farms, the water very quickly falls below the surface. And so you can't see it from ground level, but from the air with something with a near infrared, it jumps out at you. And you can spot irrigation that's leaking hundreds or thousands of gallons over time with a single drone flight. So being able to move outside the visual spectrum is one other thing. And the most important thing is time. We can see change over time. And the one thing you can't see, right here in the 3D space, we can't see what was here a day ago or what will be here a day from now. But drones have the ability, because they're constantly scanning, they're covering the same area in the same way, and recording it all, we can actually use the slider and move back over time and see change over time. And that's often the most important thing.
So in effect, let's say you were looking over a city or something, and there was a crime that was committed or something with let's say a car chase or something, you could actually reel it back and actually see that.
Yeah, so there's an experiment being done. There's actually quite a good Radiolab podcast called Eye in the Sky, which I'd recommend, came out about a month ago about this. So there's experiments being done right now. It started with the military, the kind of, the IED inspection. So it's with the military, you'd have an explosion, and it's like, okay, well, there's an explosion there, but how did it, who caused it? How did it happen? But if you were taking a picture of the entire city every day or every hour, or every minute, or maybe even every second, all the way through time, you could then move backwards. You could sort of say, okay, well, the explosion happened here. What was going on there an hour earlier or a day earlier, et cetera? And then you can just sort of, you can look back. It's almost like the opposite of precogs, right? And from Minority Report. So then they took that military technology and they applied it to Dayton, Ohio, took at crimes, and they applied it to Juarez. And they were able to, when something happened, there was a tragic story of a female police officer who was murdered by the cartels in Juarez. And they just said, okay, she was murdered there, and they just sort of caught that spot, and they started playing the tape backwards. And they watched the cars kind of cluster and park and wait for her. And then they watched after, and they kept moving backwards. Where did those cars come from? They all kind of came from one house. Then they moved the tape forward, and they watched the cars then go from, after the murder, go back to that house. And they were able to actually crack the biggest cartel in Juarez by just playing with the fourth dimension, by playing with time. Now that's super creepy, right? I mean, and there's lots of things to worry about, but it's also super powerful. And I think we as a society now have that technology within our grasp, and the question is how we're going to use it.
By the way, if people have questions here, because this is stirring up a lot of interesting questions, do write them up, and we'll basically bring them in here in a minute here. Well, let's think about that. I mean, to what extent there's a lot of opportunities here for what we could do with this thing. Before we kind of get into what could be some downsides of that, tell me about what's standing in the way of essentially accelerating this space, opening this space up. I know there's been talk about regulations of airspace in some minor ways around these kind of the current drones. But what would it take to really kind of move this into a different plane, to really accelerate this space in a way? What's missing that we need to happen now?
Well, there were two things. One is ease of use, sort of accessibility, and the other was regulation. So accessibility is kind of done. That's the great thing about this consumer-driven one, is that it done. So right now, you are all being surveilled, by the way, by that drone. It just uses it's just a camera. It just uses a phone. You just press a button on the phone, and the thing takes off, and it orbits around you or does what you want. So no piloting is required. These are fully autonomous vehicles, and they're driven by phones, or even they're connected to the internet. So you can control thousands of them from afar. So the whole sort of piloting, the human in the loop, the sort of a skill part is gone. We've now made it so you don't need to be a pilot. The next part is the regulations. How do we make it so these things are trusted and safe to be used in things like agricultural uses? So right now, the FAA allows recreational use. Like my children can fly drones, but they don't allow commercial use. So trained professionals, no. Small children, yes. We can talk about why that is, but it is. Also, you can't fly above 400 feet, beyond visual line of sight, and things like that. So why do we have these regulations? And that is because the FAA is really concerned about airspace safety. And the concept is the notion of pilot and command. A human has to be in the loop to ensure that the drones are not going to hit anything, et cetera. So the same thing, by the way, with autonomous cars. You need a hand on the steering wheel. If you take the hand off the steering wheel, then the rules change. So we need to ensure that these things are better than human, that they can navigate space, environmental awareness, sense and avoid, integration with air traffic. We need to make sure that they're better than humans before the FAA will allow them to operate without humans. And so that's an AI, machine learning, sensing challenge that is, one of the big grand challenges, very similar to the autonomous car challenge. We use many of the same sensors, radar, computer vision, multiple sensors, LiDAR, things like that. So these are the same problem on the ground is being solved in the air so that we can not only, match human abilities, but exceed them.
Is that like 5 years out kind of feeling that's going to get solved? Or
it doesn't, it's not like, sort of like it's like, and now it's perfect.
Yeah.
In the same way with autonomous cars, you end up with sort of assist technologies. So like, with autonomous cars, it senses the car in front of you and will sort of brake, or it'll stay in lane, or it'll park. And the same thing with drones. They'll start by avoiding the ground. Then they'll avoid big things like trees and buildings. Then they'll be able to avoid smaller things, and then eventually they'll be so trusted they can be allowed around manned aircraft because they can sense them.
There's a few questions from the crowd here about good questions about kind of the negative possibilities here. Like, what level of privacy should we have over drones, and how can that be established? There's this worry about watching over the. So, yeah.
I'm just going to let this.
Let those go.
Yeah. See if this will.
And then there's another one here about drones, have been used in the military to invade and attack populations with some disastrous kind of side effects here. What do you do that could make these less of a threat in the future? I mean, there's a kind of right now a stigma a little bit attached to certain people about this. So privacy, security, how do we get people kind of comfortable with these things flying over us all the time?
Sure. By the way, this is what drones can see. This is drones scan the world like that. That's this drone autonomously scanning buildings, and you end up with that kind of resolution. So that's what they can see. It's like Google Street View, but for the skies. It's kind of amazing. This is an example where it gets less amazing because it's a really hard building. So we'll talk about this in a second. So let's start with privacy. All technologies challenge our social mores. In America, privacy is regulated around two principles. One is called a community standard principle, which is to say it's not regulated federally, it's regulated community by community. And the other is based on a reasonable expectation of privacy. So what you have with those two things is basically reasonable expectation of privacy changes over time. When Kodak introduced the Brownie camera in 20, in other words, the first portable camera. Remember, before that, cameras were all in photo studios. If you wanted to get your picture taken, you had to go to a studio, black curtain, flash and all this kind of stuff. And then a camera was introduced that you could carry with you. This horrified people, because people were going to take these Brownie cameras to the beach and take pictures of people in their bathing suits. And there was like decades of debate over whether the Brownie camera was the worst invasion of privacy ever. And eventually we came to peace with it. And the same thing happened with cell phones and the internet and Facebook and et cetera. All new technologies challenge our presumptions of privacy, and every generation decides how they feel about privacy anew. So there is no answer to how much privacy, what is our reasonable expectation of privacy. So today, go to your house on Google Earth. You've been looked at by satellites for 40 years. Pretty low resolution. Now you're looked at by planes. Pretty good, better resolution. Still, but still comes by maybe once a year, and you can't quite read your license plate. Now you go to Google Street View, and now they're coming by about once a month, and maybe they can read the license plate, although they tend to blur it out. And then, and then the drones will replace the planes, and basically it's the cadence and the resolution of your surveillance is increasing every day, and that's just what technology does. And, how do we feel about that? Well, that is up to us to decide. There'll be the benefits and there'll be costs. Every community will feel differently. The Germans will feel differently than people in Berkeley. And we are going to have to continue to have this dialogue with ourselves and how we manifest that in regulations so that we are protected in a way that feels appropriate. It feels that that has that reasonable expectation of privacy has been withheld, has been maintained, but not that we ended up shutting down promising technologies. So we don't ban the internet, even though our personal information can get out there. We don't ban cell phones, even though pictures are taken of us, because we can see the positives. So we're just going to figure it out. What's ironic, of course, is that the airspace is regulated at a federal level by the FAA, but privacy is regulated at a local level, and yet the local communities don't have any authority to regulate the air. So there's like this jurisdictional mismatch. And all these cities and towns are sort of saying, okay, we're going to ban drones. And then it's like, you actually don't have any authority to ban the air. You can ban who uses it, you can ban your employees, you can ban the ground, but a decent vertical leap in the national airspace, you're in federal territory, and the feds don't control privacy. So total mess. It's going to take us decades to figure this out. And that's the story of technology.
We got a little bit of time here left. Again, if people have some questions, do bring them up here. But there's a question here that's more of a positive one to kind of really think, again, fill out the vision of how this can really be helpful. It says, can drones help fight climate change? And maybe what I'd also add to that is, like, if this really does fill out the way you can see it happening, like, what are some things that people aren't thinking about now that we could actually do with these things that would actually make a very positive impact that would be worth the trade-off, let's say, on some of the privacy issues?
Absolutely. So there's a huge, I'm not into this because I want to fly things. I'm not into this because I, want to take videos of my family all the time. I'm into this because I really see the power of closing the loop on the world, which is to say, you can only manage what you can measure. We're really good at managing data. We have the internet, we have big data, we have analytics and all this kind of stuff, machine learning. The ability to manage the planet as well as we manage the web is what's really exciting to me. So the things these are bringing, so I showed you the agricultural use, but these things are, again, they're just sensors in the sky. They can measure chemicals, they can measure radiation, the sun radiation, they can measure the forest, they can measure the albedo, they can measure reflectivity, they can measure the health of chlorophyll, they can measure algal blooms. They can measure deforestation. They can. As a matter of fact, they're really good at spotting deforestation because that's something you have to do from the air rather than the ground. They can count endangered species in a way that humans can't because they can see the nests of the chimpanzees, or they can measure the sound of the endangered bats. These tools used to be for the military or for or for scientists with expensive grants. These tools are now that's less than $1,000. These things are available to anybody, to even children. And the drone's now talking to me. These things, this powerful remote sensing technology is now available in Walmart. Just imagine if kids as a science project could do like legitimate measurement of their local climate, local environment, and then baseline it and add it into a global database. Just think how useful that would be.
Absolutely useful. So 20 years from now, when again the next generation, because you talk about the differences in privacy, but it's clearly a generational thing too. You could and the cost of these coming down, as we know the digital technologies keep driving down. Do you see this as a kind of a ubiquitously kind of covered planet that essentially around the world will essentially have in real time, essentially constant and instant kind of multi-layer of information coming at us all the time?
I think it's going to be like cell phone towers, which is to say we're going to put them where we want them. I think farms, these are going to be completely common over farms. You know, our kids will grow up seeing drones over farms the way we see crop dusters over farms. It's just, you know, just like sprinklers out there. They're just these things that charge themselves and go off and do the, you know, the daily farm scan. I think over things like construction sites, other private land, these things are just part of the, right now, these things are scanning construction sites right now. Scan vans go around and digitize these things so you can manage them. So those are kind of commercial applications that I think would be commonplace. Amazon has obviously talked about drone delivery, and you know, I think that the sort of delivery to your home is probably a little bit the ways out there, but delivery to like a drop-off zone at the top of an apartment building or delivery to a 7-Eleven, you know, that's probably going to happen in the next few years. Obviously, in the developing world, using drone delivery to get past infrastructure problems is easy and already happening as well. Google and Facebook are both doing that. So those are some of the kind of mainstream applications. The drones are going to be the size of your hand. They're going to be fully autonomous. They're going to cost, you know, $10, maybe even less. You know, I'm not going to say the sky's going to be dark with these things, but you know, there's going to be places where little flying robots buzzing around are just part of the landscape, and we will, you know, we have cameras on our light poles, and we have cameras and, you know, on all our buildings, and there will be places where it is, you know, decided to be useful to have autonomous drones just flying around taking pictures of things, and you know, whether that place is our cities or not is a policy question, not a technology question.
And we'll soon figure that out. Well, thank you very much. Fascinating talk. Thank you very much.
Thank you.
Congrats on the where you're at.